Our next speaker is Claire Sand. She's the owner and founder of Packaging Technology and Research and adjunct professor with multiple hats, University of Minnesota, Michigan State University, and Cal Poly. She's been a global packaging leader, and I look forward to learning more about innovations in food packaging.
So yes, I'm Claire Sand, and I've really enjoyed being part of this so far. I actually wanted the last speaker to continue on and keep going and going, not because I don't like talking about food packaging. That's my life. I love it. But I was really learning a lot. And then the next speaker is on drones, and let's face it, we just love drones, right? So bear with me. My first love in life is packaging, right? And it's true. So there's a word here I wanted to talk about, and that's the word more, and it's more sustainable food packaging. In packaging, we often see the word sustainable food packaging, but the truth is we can't have it. It just simply doesn't exist. Packaging will always have an impact on the environment. It's just simple mass balance. So what I really want to talk about is more sustainable food packaging. This is actually what I'm going to talk about. So this is the end as well as the beginning. I talk a lot with companies, and this is what they want to see first. So one of the things that we'll talk briefly about throughout the context of the talk is comprehensive LCAs and how they really need to be employed, not just from a food waste standpoint, but what's the packaging LCA as well. One of the things that we don't really talk about is collection and sorting. It's, as a friend of mine says, not very sexy, but we do need to get a handle on our collection and sorting. You know, depending on what study you read, between 15 and 35% of PET, like water bottles, are recycled in the United States. They're recyclable. It's not hard, but we don't. There's a whole sorts of issues associated with that. The two areas I'm going to be talking about are design innovation and science innovation. My whole tenet is that we can do better. In packaging, we can do amazing things, right? We can make food affordable, we can make it sustainable, and we can make it convenient. We can reduce food waste. We can be more conscious and more mindful of the packaging we create. We just need to do that and frankly focus on it. So I'll be talking about some of the impetus to do that, but also some of the technologies. So it's attainable now. This is what I call the value chain, and I wrote a book called The Packaging Value Chain. And there's a I don't know when that was, maybe more than 5 years ago. There's a chapter on sustainability. And one of the things that we talk about is how this is a whole value chain. All of these groups, and that's why this conference is so cool, is because a lot of these entities are here. Right, and we all need to work together in making sure that we have a sustainable food supply, but also sustainable packaging. What I think is it's a magical opportunity right now. I got into reducing food waste with packaging solutions in 1986 when I graduated from Michigan State. You know, job security, we still have food waste. Pretty cool. But it's still at 30%, right? It's moved a little bit where the food waste is, but it's still at 30%. A bit depressing, but that just means I have a lot of work to do. So now we have a growing urbanization. That's a real potential for more sustainable food packaging and more for sustainable food systems. We also have retail environment shifts. I'm talking about e-commerce. I'm talking about big giants like HEMA in China. And we're also getting to be we have a better understanding of what food insecurity means from a geopolitical standpoint. What does a food insecure population in a region of the United States mean, and the social implications of that? And we're also looking at the circular economy from an economics perspective, which I'm not, but many of you are, and you realize that there's money to be made. So this fuels more sustainable food packaging. One of the things we have to back up to, as I'm a food scientist by training, is why we even have food packaging. One of the conversations I had was about compostable packaging. I always have conversations about compostable packaging. But one of the things we have to look at is why we even have food packaging. And this is a food science perspective that I shared with a client. And, what is the moisture content or the water activity of a product? And that defines how we need to package that food. And sometimes it's a food safety problem, right? Like microbes. So some of the solutions that are at the bottom are food processing. But we also have food packaging solutions. This is some work that we did for ReFed that focused on packaging solutions to food waste. I can send you my PowerPoint if you'd like it, because it's a bit of an eye chart. The fun ones are the ones at the bottom, where we have responsive packaging, packaging that can actually sense a pH change and then do something about it. That's pretty cool. It's in the lower quadrant, which on the y-axis is feasibility. Not too feasible now, but pretty fun to work on. And then we have the ones in the upper part, which are improved water barriers, edible antimicrobials, in-store modified atmosphere packaging, and some other ones that can save a lot of food waste dollars. So I'm going to be talking about design innovation, and then I'm going to be talking about science innovation. People like me, scientists, consider science to be design innovation, so there's a little bit of an overlap here. Sorry about that. I realize that some people might consider this science. But there are three areas that we basically look at in terms of design innovation, and that is designing recycle-ready packaging, packaging that's ready to be recycled. And then we also have single-component materials, and then we can redefine packaging. So I'm going to be talking through these different concepts. I'm not going to be talking about all of them in the interest of time. One of them is chemically recyclable polymers. There's a lot of research that needs to be done in this area. Big players like Coca-Cola and allied businesses are working on this. And we can do it with a variety of different methods. And we can use it now with polyethylenes. And we do have bio-derived and biomass-derived and recyclable polymers. And these polymers can be recycled with chemical recycling. It's expensive, right? And we need research to make sure we can do that in a much more economical fashion. What chemical recycling means is we can get down to the monomer level in PET, for example, and make PET into polyethylene terephthalate and all the different monomers, and then we can reuse the polymer. We can't do that as efficiently with chemical recycling. These are biomass-derived and recyclable polymers. And what I mean by biomass is they're derived not from oil. And by recyclable, I mean they're recyclable in our existing systems. So these are all substitutes for polyethylene, right? So a drop-in substitute, which industry loves drop-ins. So you could take polyethylene and just use biopolyethylene instead, and it's recyclable. You can use PET or biomass-derived PET as opposed to regular PET. So this exists on the market now, and we're using these as consumers. One of the other areas with design innovation is to use, I guess you could call them little dots or little nanoparticles within a structure. So an example would be a high-density polyethylene milk jug that you have, but making that a better barrier by putting little nanoparticles, and those nanoparticles can actually be composed of high-density polyethylene particles. So you create a higher degree of tortuosity, you create a higher barrier, but the whole structure is recyclable. And we're doing this now, and we're doing it more and more with much success, but we do need more research in this area. This is making a high barrier structure, but also recyclable, which is pretty rare in the food packaging industry. Something that I was talking about at lunch today was pretty interesting, and this is a way of rethinking how we package food and even why we package food. Separating what we need to do as manufacturers, which is high efficiency production lines, producing massive quantities of the same food at the same time, with what consumers need. They don't need massive quantities of food at the same time, and they also don't need food to last 24 months. So some products that I'm going to mention here are just examples, but if we take little tiny chip bags, like whatever brand you might think of, and right now they have a lot of packaging. The product to package ratio is pretty high, and they're also not recyclable. They're typically made out of metallized film. But if we take those and we put those little tiny bags, we replace the metallized film with paper, and we put them in a giant container, right? And that giant container has a modified atmosphere. let's say nitrogen, which is used in the little chip bags, and is a high barrier, we get that shipped to the store. It's unzipped at the store when it needs to be used, put on the shelves, and then consumers who consume those little tiny bags of chips, probably or at Subway, maybe in the next 20 minutes or so, they don't really need 6 weeks shelf life or 12 weeks shelf life. They need a short shelf life. And it's something disposable, like paperboard, that consumers consider to be more sustainable and that we can recycle in our existing systems. That's an example of rethinking how we do things. And you may say, well, Claire, how did you come up with that? Well, we've been doing something very similar in the meat industry for about the past 20 years, and that's the master pack concept. But expanding that whole concept and making it returnable, making that bag returnable is something we add to the system, and making the package, in this case the chips or the meat, more sustainable is something we need to add into that. But we've been doing this concept for years. It's not that hard. So that's what I consider design innovation. In terms of science innovation, there's all sorts of cool stuff going on. We have two fields I'm going to talk about: active packaging and intelligent packaging. Active packaging is when the package actually does something, right? And there's much discussion about, well, all packages do things, but anyway, do more. And so we have modified atmosphere packaging, moisture, odor, and containment, antimicrobials, and what we call kind of flow management. And I'm going to be talking about just a few of these. The first one I'm going to be talking about is oxygen absorbers and CO2 emitters. Oxygen is one of the things that really degrades food. Whether it's lipid oxidation or microbial growth, oxygen really affects our food. So we have odor-absorbing sachets, and we have CO2 emitters. This is from the work we did for ReFed, and this estimates how much can be saved in terms of food waste dollars by implementing these different technologies just at about a 10% level in the food industry. Another solution is edible antimicrobials. Now there's a lot going on in there. Edible packaging is something kind of strange, and then then I just added edible antimicrobials to that. Cinnamon is an edible antimicrobial, right? It retards a lot of microbial growth. Not all microbial growth, but some. And so we can use things like that that are grass, that are acceptable in our food system, to spray on our products, to increase the shelf life of our products. And we do this now in the food industry. We like maybe not to talk about it with consumers so much, but we can expand the use of this, and that can greatly increase shelf life of products. Intelligent packaging encompasses a wide area. I'm going to get into these time temperature indicators. The first one is consume within, and this is what the companies I work with are telling me they need, that their consumers are saying they need this. And that's opening a refrigerator and something will say consume within. That means if you buy a salad on Monday, but you look at it on Thursday and you don't remember when you bought it, it tells you, oh, eat by Saturday, right? So that's, personally, I would love that. Anyway, that's what my clients are telling me consumers want. We also have freshness indicators, microbial indicators, oxidation indicators, and time temperature indicators, which are sometimes called time temperature integrators. The first one is CWI. It's pretty cool. There's an example here on Kraft Mayo, which, boy, that lasts a long time, right? So anyway, so when it's opened, it's actually activated, which is pretty cool. And then it tells the consumer when it's going to go bad. Well, how does that work? It's a time temperature indicator in this case, and it measures the amount of time that's lapsed, and it measures the amount of temperature, which means if you sit it outside on a picnic, it's going to change a little bit, faster, which is good. There's some other ones that are pretty cool, and these measure microbial growth. One would measure CO2 dropping, one would measure a reaction that takes place within meat systems, and in this case, the aluminum layer would dissolve. We also can measure the amount of volatile gases, and then we can link that to an indicator. Right? Volatile gases tend to change the pH of the whole system, and we can measure that. We also can measure the release of hydrogen sulfide, the presence of bacteria, why a lot of food goes bad, and changes in pH. So these are time temperature indicators, intelligent packaging, CWI type indicators that are on the market today. This one at the bottom here is that measures CO2, and that's Van probe. So I talked a lot about time temperature indicators, and time temperature indicators have been around since about 1975. So I have a lot of friends who work in university research, and they just invented something called a time temperature indicator, which is pretty cool. So we continue to research these areas, right? But I'm a big advocate of let's just do it. I was talking with a woman about food shelves and food banks and things like this. If we had consumed within via TTI, time temperature indicators, on the products that are shipped from retailers to food banks, like in critical products like meat, and that would guarantee that a product, or you would be able to see if a product has achieved a cold chain of custody, and would also give people who are food insecure more confidence in the food that they're getting. So there's a lot of applications for consume within via TTI. I mentioned this because this technology, unlike the CO2 and hydrogen sulfide and things like that, is pretty low tech. The technology to do this has been out there for quite some time. I may be the only one who's going to end on time. So this is cool. I like this. So I can't tell you how much I believe in LCAs. I love to read them, right? There's a lot of people who are advocates of holistic LCAs, right? And I kind of like that as a concept because there's no real need to get out to 20 decimal points. But in general, we really need to have a conversation about food waste and sustainable packaging. As I mentioned, I've kind of dedicated my life to food waste and packaging solutions to food waste. But now I can't really have a conversation with people about food waste or packaging solutions to food waste unless I talk about sustainable packaging. But we see countless, and my company just did a big study on sustainability and food waste and sustainable packaging. But we see the impact of sustainable packaging on the environment, or packaging on the environment, and we see the impact of food waste on the environment. And by and large, with the exception of products like water, where we have packaged water, the impact of food waste on the environment is much greater than packaging on the environment. It just is. Pick a metric: greenhouse gases, water use, everything. Right? We have some more sustainable packaging alternatives. I'm not saying we shouldn't use those. I'm saying we should. But we also need to have a larger conversation about using packaging more effectively to reduce food waste, because we can. But we need to make sure that packaging has a role to play and continues to have a role to play. We also need to invest a lot in collection and sorting. If we really want the circular economy to be effective, we need to collect the product, whether it's in the ocean floating around in the Pacific garbage patch or whatever the current name is, or on the city streets, or in trash bins when it shouldn't be, or in recycling bins when it's not recyclable. We need to do a better job at this. There's great groups like the Sustainable Packaging Coalition who have a how to recycle label. This is not hard, right? We just need to do a better job communicating with consumers and understand that not all of them want to pollute the world, right? Not all of them wake up every day and say, I'm going to do something really bad for the environment and throw a bottle in the ocean. But we need to give them very specific direction. And likewise, we also need to understand that in a lot of the origin of a lot of the plastic and packaging in the Pacific garbage patch is outside the United States, and is countries where there's health compromised people living in those countries and in the regions along the rivers. And so they're frankly people who have other things to do than worry about how they dispose of their waste and their trash. They need to make sure that they can eat, right? But we need to provide those populations with much more sustainable packaging that is blending with their type of environment. So there is much hope. There's much work to be done, but I do think we're moving in the right direction. And I really think that groups like this and the cross-disciplinary approach is the way to go. So there's design innovation for more sustainable food packaging, and there's a tremendous amount of science innovation for more sustainable food packaging. And thank you for your time.